Okay, now in this section, we'll try to understand the WAN connection, how it is built with some basic understanding on the lease lines. If you just go back with some of the basic classes, what we have done, we have already seen how the LAN setup is built. So in the LAN setup, generally we have some computers in the LAN, probably computers, and all are connected to a centralized switch via a straight cable, the UTP straight cable which we use, and even the same straight cable is used to connect from the switch to the router. So same thing in the LAN. But now the question is, what about the WAN connection? How the connectivity from my Hyderabad branch office or to Dubai branch office, different locations, how these two particular branch offices are going to connect. What is the different kinds of WAN connection we need to use, where I can allow my branches to connect. Now to make that possible, what we need to do is we need to contact the service provider. Now we need to contact the local service provider or any service provider who can provide you the connectivity. Okay, which means the cable which is required for you to connect between your own branch offices has to be provided by the service provider, because I cannot lay my own cable from one location to another location. We need to take a line from service provider. Now there are different kinds of connections which generally provides. Initially we have something called lease lines, where we can have a separate dedicated WAN connection given by the provider, and then we also have some kind of a circuit switching technology where some telephonic network or telephone network can be used for sending your data uh, from one location to another location. Or we have some packet switching technologies like frame relay, ATM kind of technologies which can be used for providing the connection. So more on detail on these lease lines, ISDN and frame relay kind of connections, I'll be getting into that more in detail in my next sections. I have a separate section dedicated for the WAN technologies, and even I have some more kind of WAN connections which are used in modern networks like MPLS, Metro Ethernet, VPNs. Probably I'll be getting into this kind of these different types of WAN connections much more in detail in a separate session where I'll be discussing on WAN technologies. Okay, so at this point of time, I'm going to give some idea on how exactly the normal basic lease LAN setup is done. Okay, so let's take an example. I got a LAN here, which is my Hyderabad branch here. I got all the computers in the LAN, and they all are connected to my centralized switch. And the same thing here also, I got a centralized LAN where I have all the computers connected to a centralized switch. Now I want to ensure that the user sitting in the LAN in Hyderabad should be able to communicate with the users connecting on a different network. So for that, I need to contact the service provider who is going to provide me a line which will be connecting from one router to another router. So let's say I contact one of my service provider and he's going to provide me a lease line connection. And let's try to understand, when you take a lease line connection, how it's going to be. So in general, when you take a lease line connection, the router connects to a lease line modem, generally called as CSU DSU modems. So we call them as CSU DSU modem, channel service unit, data service unit modems we call them as, or we can call them as V.35 modems. So these are typically your lease line modems which are provided by the service provider and placed in your location, and typically they look like this. It depends on different kinds of devices. You can see it's a live diagram where you have a serial cable connecting here. This is my serial port, and I got that V.35 cable here, and this V.35 cable is going to connect to my modem here. On this modem, different types of converters are there, and then from there you got a service provider line which is coming and connecting on this particular modem. And this is a normal connection, we can say. And this is my LAN port which is going to connect to my switch. It's going to connect to my switch from where all my users sitting in my LAN are connected. So typically, it looks like this. It's just a small diagram here. Now this part we call as customer premises equipment, and same way here also we call it as customer premises equipment. Now if anything goes wrong up to here, it is the responsibility of the customer to ensure that, to fix it, because it is a customer premises. If you find any cable issue, connectivity issue here, it's your job to fix it. Any problem in the LAN between the computers to switch or switch to router, switch to PCs. It's your responsibility to fix it. Now after that, it's not my responsibility. So from here, it's something service provider boundary starts here. This is a complete service provider boundary here. Now what service provider will do is, service provider will have a 2-pair wire, mostly a 2-pair wire, which is going and connecting on the exchange office of the service provider, nearest exchange. And there probably they use some G.703 modems, typically long distance modems we can say. And from there it's going to connect to a big device called MUX here, a multiplexer. Same way, you got a 2-pair wire which is coming from your router to going to another modem over there, and then connects to a big device called MUX. Now from MUX to MUX, there is a fiber cable which is pre-existing fiber cable laid by the service providers, and which is connecting the major cities. There is a fiber line which is already laid by the service providers, which is connecting different cities and different countries, and the service provider will have the service provider will have a pre-existing line connecting all the exchange offices. Now in this, if I just talk about like what exactly MUX is going to do is, MUX, if you know, MUX is multiplexer, we can say. Multiplexer is a device which is going to provide multiple signals. Like take an example. I got my Hyderabad branch office here, and this is the exchange office. And if you just think about a normal way, like in Hyderabad, I'm not the only customer who is taking the line. So there might be another customer also connecting on the MUX, and I got another customer also connecting on the MUX, and also one more customer connecting on the MUX. More similar way, like I got a connection here and another customer connecting on the MUX here. Now the multiplexer is a device which is going to allow you to send, even though they might be going on the same cable or same fiber cable, but still multiplexer allows you to differentiate the signals, each and every signal, so that they don't interfere with each other or they don't disturb each other. So something like that. So that's something what multiplexer is going to do. It's going to do this kind of job in the service provider networks. So mostly we have nothing to do over here, because that is not in our control. We have nothing to do here on this particular part. Our job is on the router 1, on the router 2. Our job is in the LAN, and our job is in the LAN. And this is something what given by the service provider. We are just trying to understand how the WAN connection is built by the service provider if I am taking a dedicated lease line. Okay, so this is how the WAN connection is built by the service provider. But when it comes to our side, we don't really bother much, because as long as we have a connection, we don't really bother on that. So this is how the typical WAN setup is built by the service provider if you are taking a lease line connection. So in this setup, you got plenty of devices involved, like the modems, MUX, and the routers. We got a lot of devices involved. And depending upon the kind of the modem you're using, on the CSU, DSU, you have different types of converters. But this end will be connecting on the router, and this end will be either 60-pin connector, the one which we use, or it can be 26-pin connector. And the other end of the cable, it depends upon the different modem types, the CSU device, CU device kind of thing. Now the next thing we need to understand, in this setup we got two different kinds of devices. We have DTE and DCE. Now DTE DC concept is more like if you are using a dial-up internet connection. Let's say I'm going to connect my PC, and this PC is connecting to my modem. Let's say I'm connecting to my modem, one of the modem, dial-up modem, and then it is connecting to my telecom line, and from the telecom line probably I'm trying to access my internet or other job. Now in this setup, if you just try to see my PC is generally we call as a DTE device, and the modem we call as DC device, data communication equipment. Now what this DC is going to do is, it is going to generate some clocking, so which is going to generate some speed, which is going to allow you to send the signals for longer distances. Okay, so it's going to generate some signaling which will allow you to send over longer distances over the service provider network. So this modem is responsible for generating that clock speed, we call it as. Okay, in other words, we simply call it as clocking. And whereas the PC here is not going to do anything, it is going to just accept the signaling and that's the only thing it is going to do. Okay, so the same kind of setup we have in our routers also. Here also we got some DC device, which are more like a service provider devices, and then we got a DT, that is my router. So if you want to have a communication from DT to DT, you need to send over the service provider network, and service provider network for longer distances we need some modems which will do some clocking, which will generate some clocking, which helps your data to send over longer distances over the service provider network. Okay, so here also we got some DT DC devices. Typically these are terminologies which we use for identifying the different kinds of devices. So this is how the real WAN connection you will have in general in the production networks. So in our labs, what we are going to do is we are going to use one cable called back-to-back cable. Now the back-to-back cable, it will be 60 pin on both the sides, or it can be 26 pin also. So you'll find some back-to-back cables which can be used. What we are going to do is we are going to have two routers in the same location. So which means I have a router here in Hyderabad, so probably, and here one more router here, and these two routers we are going to assume that they are in the same location. They are in the different locations, but practically they are in the same locations. And then I'm going to connect this cable, one side of the cable on this port and the other side of the cable on the other port, and then we are going to connect this back-to-back cable between the two routers, which is going to emulate my complete copper wire modem and MUX setup. So which means in my lab scenarios, I'm going to use this back-to-back cable for providing the connectivity between the two devices. So if you want to set up your home lab, probably you need some back-to-back cable which is going to simulate the complete exchange setup in your labs. Okay, so we don't use a real WAN connection, which is something not possible in simulating in the lab scenarios.